welcome back to another 3 Caillou challenge called Texas Hold'em Hands. Hopefully it's a very famous game, Texas Hold'em Poker. Go ahead and read through this in case you don't know what it is. It's basically a game where players can work with 7 cards and they're trying to make the best 5-card poker hand out of them. There are some cards that players have unique to their own hands, and there are community cards, and you can combine them in whatever way makes the best 5-card hand for you. So they are kind enough to give us the hand ranks in order. So you have a straight flush, 4 of a kind, full house. This is going from in descending order, so best hand to worst hand. Straight flush, 4 of a kind, full house, flush, straight, 3 of a kind, 2 pair, pair, and nothing. And so they'll provide us the whole cards. Those are the ones that any individual player has, and the community cards. And so we have to determine the best hand for a player given these whole cards and community cards. And you could imagine you could use this function for every player at the table, where the community cards would be the same and the whole cards would be specific to that individual player. And you could calculate everybody's best hand that they can make. Notice this edit straights with an ace. Only the ace high straight is accepted. An ace low straight is invalid, so you can't go ace 2, 3, 4, 5 using the ace as a 1. This is consistent with the author's reference solution. That's fine. The other thing that may seem weird too is that they don't have a royal flush, but you can think of a royal flush as a type of straight flush. The best straight flush, where it would be ace, king, queen, jack, 10. Yeah, so I think it's pretty clear what to do, but obviously some thought goes into this. So I'll let you go ahead and think about how you want to do this while I do a little setup here. And you know what to do. Pause the video, give this a try. I'm going to go over my high-level design plan, and so if you want to watch that first before coding, if you're stuck on ideas, you can watch that, then pause and start. So this isn't quite UML, but I tried to do something UML-like to show you my idea. And so hopefully you can see this okay. But basically my approach is going to come down to this. I'm going to have this base class, and you can see I noted it's abstract. It's going to be called handmaker. And the idea is that I'll have all these different subtypes of hand makers, right? You can see they're dedicated to each possible hand. A pair, trips would be 3 of a kind, straight, full house, straight flush, quads would be 4 of a kind, and then a flush one. And so the idea is that once I have all these different types, I'll have this win analyzer class, right? And it will have a collection of hand makers, and it will have one of each of these concrete types in there. And so when it offers a simple public method to make a hand given a collection of cards. And so all it will have to do then is go through each of its hand makers, right, in the collection, call get hand for it, and then it will be able to see which is the best hand, because what I didn't show, well, you can see I'm going to use a struct here called hand, and so it'll have a win name, card ranks. We'll see this is the return type the instructions ask for. But note I also added this extra weight field. So the idea is when I have all these hands coming from all these hand makers, I can sort them by their weight and then just take the one that has the highest weight. And I'm doing that with this win type here. You can see all the types enumerated. I started one at 0, and their value increases as the hand gets better. And so if I sort by this enum value, my first entry in that collection, that sorted collection, will be the best hand. And if there's none of these win types matched, then basically we'll just return the best 5 cards, the highest ranked cards that are unmatched and don't win. And then you can see I'll have some extra little data types here, a struct here, a card contains a suit and a rank. They didn't do this in the challenge. I wish they'd been a little bit more organized, but they're kind of just using strings. But I'll use this. It probably isn't entirely necessary, but you know, it's a little cleaner. I like it. So hopefully that's clear. You can see what I'm doing here. I have all these hand makers. I can just feed the cards in. Really simple, right? I just feed all the cards into each maker, get the hand. Remember, each maker will try it. So like if we have the flush one, it'll try to make a flush, but if it can, it'll just return 5 cards. And we'll have, we have this win type too. So if they don't make a flush, it'll return nothing, which would be the lowest ranked. So that said, hopefully that's clear. There's going to be more code than this, but I just wanted to keep this simple, and so you can really see the general strategy here. And maybe you were stuck on ideas, and you can take this diagram and implement it. And that's what I'll go do now. So if you need to pause and make note, you can. I zoomed in a little bit so you could read it a little bit better, but let me see if I can zoom out. Get everything. Okay. So yeah, I'll go implement this now. Let's go to work. So this is what I was talking about, the return type, right? They got this anonymous type here where you return some string denoting the win name or nothing, and then a list of all the ranks. Notice they don't have anything to do with suits. They're just, it's like they ignore the suits. They don't care about it, which I don't like, but that's what they want. So good. How should we start this? I think the first thing to do is you'll note that these characters, right, they're using actual playing card symbols here. So I did something to try to figure out what those values were, because, you know, I don't know them off the top of my head. So let's do that. I'm going to add some print statements to help us out a little bit here to start. So we could say for each string card and whole cards, right? Do something like console, right line, whole card. And you could do the same thing for the community cards if you like as well. And so if we run, you can kind of see this format that they have here. Console doesn't exist, that's fair. Remember the system namespace. I apologize if I over-explain some things. I bounce around between Caillou levels, so I'll try to keep it to a minimum here at 3 Caillou, but in general I like to err on the side of explaining too much than not enough. So yeah, you can see how these cards are coming in. They've got a rank and a symbol, a suit. And one thing I want to warn you about, you know, it almost comes out really clean where you've got one symbol for a rank, one symbol for a suit, but you will notice that 10 is a card, so it isn't, you can't count on each card having only 2 characters, so make sure you handle that too. All right, so let's figure out the values for these symbols. So one thing you can do is like this. You could go suit. Let's just add the suit. And it would be card length. We're gonna, remember cards is string, so I'm gonna say the length minus 1 means just grab the last character, right? And what I can do with that char is I can convert it to an int to get the integral value. Let's see if this works. So yeah, here are some values. You can see clubs is 9827, 9829 for hearts, diamonds. We didn't have any spades there, but we can put this up above and let's see what spades is. 9824 for whatever reason. There's a a gap there. But that may come in handy later. So what I'll do is, where should we start? Should we make the hand maker base class? That's, yeah, I think that seems like a good place to start. We'll make that abstract class first. Okay, let's do that. So I'm gonna make a new class. I'm gonna make sure I'm outside of this kata class. Public, and I said we're gonna make it abstract because it doesn't make sense to instantiate anything of this. This is gonna be overly generalized, and so I'm making it abstract. I don't want anything to be created out of it. It just kind of sets up the framework. Abstract class hand maker. Good. And then we'll get a constructor hand maker, and from the diagram, the UML, we're going to have this win type that will pass in, right? Because each one we want to know how it should be weighted, right? A pair, a 3 of a kind, a 4 of a kind, whatever. So we're going to store that data locally here. To that end, I will make a protected win types. I'll call it weight, but you could call it win type too if you want. And then once you get that information, just make sure you assign it here locally. And then the only other thing we really need here is this public. This is also going to be abstract because I'm not implementing it here. It'd be impossible for me to implement something because it doesn't represent a real hand strategy, right? I don't know if I'm looking for a pair or a straight, or I can't make any assumptions here. That's why I'm just calling it abstract. And when I call it abstract, it means I don't have to provide a method body here. So it's going to return a hand type. Hopefully you remember that from the diagram. And I'll call it get hand, and it's going to take in an array of cards and make the best 5-card hand. So that's it. Abstract class, right? Just each type will return you a hand trying to get a hand of the type that it is designed for, if that makes sense. So and this is protected, which means every subclass we make of hand maker will be able to access this field. Good. So now I'll go into making some of these concrete hand maker types, right? We had pair and whatnot and all those. So let's start with a pair hand maker, not too complicated. Public class pair hand maker, and we're going to inherit from hand maker. Whoa, not caps. Okay, we will start with our constructor here. And I'll say pair hand maker, it's just the name of the class. And then remember, you can call base to invoke the superclass is constructor, which is this one. And before I get into this, actually, let's make this win types since we're working with it now. I'm gonna make some enums here. Let's do it right here. Public enum win types. And so our win types are nothing equals 0, pair. They'll automatically increment by 1, but if you wanted to, you could explicitly write each value there. But if you don't, the default behavior is it should just increment by 1. We've got 2 pair. Next would be 3 of a kind. Then we'd have a straight, a flush, I think 4 of a kind, no, full house, 4 of a kind, and then straight flush would be the best hand. Okay, good. So now I can work with this. It's actually implemented. And so with our, note that the base class takes the weight. And And because I'm in the pair handmaker class, I'll just set it right there. I'll say when types pair, right? And so that information will be stored for the class. Will have the weight associated with it, which is good. When types pair, then we just have to implement that get hand method, right? So I will say, and we need some curly braces here. Now let's implement that get hand method. Public override returns a hand. Get hand takes an array of cards, which we should also set up. And we need a body here to do the actual work of getting a hand. So before I get too far ahead, let's go implement those hand and what was the other one that I have to make? Hand and card classes. So we had our num there. Make a little space here. And so we can say, let's start with card. We'll say public. I'm just going to make it a struct since it's like a little data type. And for my card, it's going to have a suit and a rank associated with it. And those are the two fields that will be in the class. Let me go ahead and add those. Char suit, public string, rank. And then in the body, we can say, suit, capital equals suit, rank equals rank, nothing amazing there, right? And then the other one, let's go ahead and take care of hand too. Public struct hand. And for our hand, we'll say public hand for a constructor, string when type, and then we'll have some cards, and then a weight. And those will be our, those will be our fields. So public string when type will go public string array cards and public int weight. And then in the constructor, as you can imagine, when type equals when type, cards equals cards, weight equals weight. Okay, so now we can, these things are valid now that we've implemented them. That's good. So we're back to the implementation of a pair hand maker given cards, and now we know what cards are. They have a suit and a rank, right? So how do we scan the cards and check for pairs? So let's do it like this. Let's bring some LINQ in here. Var, and I'll call it pairs. And we could say pairs is equal to the cards, and remember our handy group by method that will take the elements of the card array and group them by some criteria we give. As you can imagine here, we care about the rank because that's what is getting paired up. We're not pairing suits, we're pairing ranks. So we could say cards group by card rank, right? I use card for my variable name and my lambda because each of these are cards, and we know it has a rank property. So they're just putting them together, right? So it'll make these groups, and hopefully it's clear we're concerned with the groups that have a count of 2, right? That means it's a pair if there's 2 of them, right? So I can say group by where, I'll call my variable name here match, and I'll say match.count equals 2, right? That's a pair. So I'm filtering, right? This where we think of as a filter. And so now after this part, I'm left with things where the count was exactly 2, so all the pairs. If I'm dealing with 7 cards, I could have up to 6 pairs, right? And so we want to select these by their rank. Remember, group by already put them in their rank, so I can say, here, I'll start this on a second line so you can see. Select match key, which was, the key is the rank because that's what we grouped by. You can see this group by, if you want to read the docs, refresh yourself. I think it's an iCollection type, or we've gone over it in other videos, but feel free to refresh yourself if you like. Anyway, we selected those ranks, and then we're going to order them because we care about, we want the biggest pairs, right? We don't want the 2. It could be, you got 3 cases, right? You could have 0, 1, or 2 pairs. And so we're going to order them from high to low, and then we'll try to take 2 from that. See if we can get 2 pairs. It won't give us 2 if there aren't 2. And so you can do an order by descending. We've seen a number of times now. And before I implement this, we need a way to order these, right, by the rank. I can't just say do it by the rank because the rank is a string, right? And we don't order pairs by alphabetical order. We want it by their by the rank's weight, right? So an ace would be a very high rank, even if it's not the best alphabetically. So I'm going to set something up to handle this. And what I'm going to do isn't exactly a best practice, but I'll use it as a way to organize our code here. Just a little logical container for doing this. So what I can do is I'm going to make this public static class utility. And I'm really not a fan of utility classes. I'm naming this explicitly this way so you can see what it is. But I'm just going to kind of put some general behavior, some general logic in here. To me, these are abused in the real world. When I see utility classes, it seems to turn into a dumping ground where people just kind of blindly throw code that they just want to access. They want access to without actually thinking about a complete design. So I wouldn't recommend doing this. For the sake of this challenge, I'll make one here. But if you want to criticize my design based on that, that's a fair criticism. So I'll say public static int, and we'll say rank weight. And it'll take a string rank as a parameter, and then we'll just tell it, we'll give it numerical values, because we know order by, if it's working with numbers, it already has that behavior built into the integers, right? We don't have to implement that. Those built-in types work with order by descending. So that's the idea. We'll just convert the rank to a numerical value. And I'll use a switch statement here. I'll say switch on the rank. And with that, let's just give it some numbers. I'll say case A would be an ace, right? And we'll call that return 14. Let me copy this and we'll repeat it for some other suits. I'm sorry, for ranks. We'll have a king, which will be a little bit lower. We'll have a queen, which will be even lower. Next goes down to a jack, right? Next goes down to the 10, everything else. So I'm going to combine those cases all together. I'm going to do it like this. Case 10, and when you want to do multiple cases, you can do it like this. Case, I think I'm doing this right. We'll certainly find out, right? Case 8, case 7, case 6, case 5, I'll just copy these. 4, 3, 2. And we don't need a 1 because that would be like an ace. 2, 3, 4. I think I got all the numerical ones now. And then in these cases, we'll just say return in 32, parse the rank. Good, and then I'll have a default just to sort of catch if any oddball behavior comes in, and I'll throw an exception in this case. Argument exception, we'll say invalid rank. Hopefully that helps us if this comes up. Shouldn't come up, but yeah, so now I've got this rank weight that I can use to convert to an integer that order by descending can handle. So we'll go back to the pair hand maker, and we can say for that order by descending, so select got us back to our rank. We'll say rank, and I can use utility rank weight. Oh, I'm sorry, not weight, rank. Rank is the variable name for our lambda, right here. We want to pass that. Utility is our static class there. That's how I'm accessing that. Order by the rank, and then I'll try to take 2. So remember, there could be up to 3 pairs, but 3 pairs isn't a hand in a 5-card poker game, right? It takes 6 cards to make 3 pair, so that's nonsense. So I'll try to take 2 there. So this could have 0 though, right? So and then we're basically gonna combine any. We have to make a 5-card hand, so we need extra cards to fill in the gaps that aren't the pair cards. If we have 1 pair, we have 2. We need 3 non-matched cards. If we have 2 pairs, we need 1 non-matched card. If we had no pairs, we'd need 5 non-matched cards. So I'll call that, let's say, var non-matched, and I can call this cards where we're going to filter these. And remember, they're cards. Each element is a card, so I'm calling it that. And I'll say not pairs contains rank, right? Meaning this was pairs right here. This got our pairs. And if the rank wasn't in here, it's a non-matched card, right? It isn't part of a pair. So that's all I'm saying there. And then again, I'll order those by descending, and we can select the card's rank. So we can say cards where order by descending, and we'll say these are still cards we're dealing with, and it'll be utility rank weight card. We have a card now, so I'm accessing the rank property there, and then I'll say select card.rank, and so this will convert it to that string, to a collection of strings that are ranks. Kind of, you can think of it like stripping the suit out, because that's what the challenge is interested in. So yeah, let's go ahead and set up this hand variable that we have to return. Hand, and I'm going to give it a default setup. New hand. Remember, if it's garbage, no wins. They use the text nothing to describe that, and they didn't list that in the instructions, but you can go down here and see what they name their things. It's not necessarily clear, like they use hyphens here, and so just make sure you match those up. So yeah, new hand nothing, and in the worst case there's no pairs, we'll just say non-match, which should be sorted already for us. take 5. We're making a 5-card hand. 2 array, because we're gonna, it takes a string array. Remember the hand class cards were an array of strings. And then we also had a weight too. We could use a weight of, what was it, 0 for nothing. Nothing is 0, so I'll give it a rank weight of 0. Good, so that's like the default, and we'll just return that if there are no wins. So we could say if pairs.count is greater than or equal to 1, which means a pair was found, then we can say, we have to actually set the fields of this hand. It's going to contain the winning data. So we could say hand win type equals, it's either going to be 1 pair or 2 pair, right? So we'd say pairs.count equals 2. We'll use that ternary expression. If that is, it'll be 2 pair, else it'll be, I think, just pair. Good, that'll get our win type. We can say hand dot cards, or card ranks it was called, card ranks, and that'll be equal to pairs, and we have to add the non-match cards to make a complete hand. Remember, pairs is an even number, you won't get 5 from that. So I can say non-matched take, and we're going to do this dynamically. We could say 5 minus pairs count times 2, right? Because each pair by definition has 2 cards. So however many you have, subtract those away from 5, and whatever you're left with is the number of non-matched cards you need. Card ranks is a string array, so we're going to convert this to an array. And then we could say the hand weight would be equal to, we'll convert it to an integer, the weight property. Remember, all hand makers had that weight field, so we'll just convert it to an integer here. And that completes the hand. And so that'll only happen, right? This conditional only happens if there were pairs found. If there weren't, we have this already built in no win hand. We should be able to simply say return hand at this point. And remember, this is the pair hand maker. It doesn't care if there are straights. It doesn't mean that pair is going to be the best hand found. You could have a hand that had pairs and a full house, right? But that's beyond the scope of the pair hand maker class. It's only concentrating on pairs. The win analyzer will sort through and determine which is the best winning hand if there are more than one ways to win. So yeah, that concludes the pair hand maker. And as you can imagine then, this process just pretty much kind of repeats for the other ones. So we're going to have a public class trips hand maker. I'm sorry, I'm not at the constructor yet. It's going to derive from hand maker. And we'll make a constructor for it, public trips hand maker base, and we're going to give it a weight of win types 3 of a kind. And notice I'm not even passing anything into the constructor here because I don't need anything. I'm within the context of trips hand maker. I can just use this to set up the base implementation there. And I don't have anything to do in the constructor body, so that will suffice. As usual, we have to override the getHand method to give the actual implementation, because that method's abstract and has none by default. And part of the contract is we have to do that. So let's do just like what we did with pairs, right? var trips equals, see if you can do it, cards group by, right? What do we group by? We're going to take the ranks. That's what we're trying to make trips out of, card.rank. And then with that, before we did where match count is going to be equal to 3. I'm sorry, I need my lambda parameter. Each one of these is a match. I'll say match count equals 3, right? Because we're looking at 3 of a kind. And then we're going to select, we're going to convert these from matches from these group by collections back to a collection of string ranks. So where match count equals 3, let's select, and we'll say match dot key. Let me put this on another line so we can keep this all visible, my tiny window here. Okay, I'm gonna indent that. So yeah, that's the idea. Hopefully I lined up all my parentheses right. It reads pretty well. Group by the ranks, right? Filter them out where you have the trips. The most you could have with 7 cards would be 2. Most you can have in one 5-card hand would be 3, and then convert it back to just this, to just the rank, right? And then the same idea. We'll need non-matched cards to complete the hand, and that'll be cards where, remember what we did last time? Card not trips contains card rank. And then these are the collection now would be cards. So let's convert it to a format that we want to work with. Select card rank. Now we get those rank strings, and we will order them. Order by descending. We have the string ranks now, so I'll call it rank utility, rank weight, rank non-matched. Okay, good. So now we have our non-matched cards. Same thing, we can make a, I mean, this is almost exactly like 2 of a kind, but was just with 3s now. So we can make a default hand object here, hand equals new hand, nothing when there's nothing, no win, and then we'll use non-matched cards. Actually, for losing cards, I suppose it doesn't matter. You can just take any 5 cards. That's not going to count as a win. So we could say cards take 5. And if you don't like how I'm using this, if you want to call that a magic number, you can make a constant, call it poker hand size, and plug that in everywhere I've used 5 if you'd like. To me, it's pretty clear here. Cards take 5, make a 5-card hand, but yeah, handle that however you like. Cards take 5. Select. We need the ranks, right? Not the cards, because that's what the answer deals with. Card rank. We'll convert it to strings there, and we'll make it into an array. We have an array of strings, and then we have a weight for our hand. And so the idea here is, if same thing, just really same thing. If trips.count is greater than or equal to 1, we have winner, and win type would be, they called it 3 of a kind hyphenated. Then we need our card ranks. Card ranks is going to be equal to trips concat, short for concatenate, right? You can combine 2 collections together, and we can say non-matched. It'll be take 2, right? Because we have 3 of a kind. Trips concat non-matched take 2, and let's convert that to an array as card ranks demands. And then we have a hand weight would equal to, it's just sort of casting our enum to a weight, which is already built in because this is a hand maker. Remember, that property got set in the constructor up here, right? That was put in the weight field. So good. Oh, and then finally, right, we have to return the hand, of course. Good. Another hand maker down. So that was trips. Let's go to a straight hand maker. We can say public class straight hand maker derives from hand maker. Copy that. Define our class scope. Make a constructor public. Don't need anything. We'll invoke the base with win types. Should be called straight. We don't need to do anything in the constructor body, but we do need to public override hand, get hand. These all need an implementation. And get hand takes an array of cards, right? That's how we defined it. Okay, so we're not doing with rank matching anymore. Let's do something a little more different. I'll start by setting up my hand to return with a bum hand. That will do if cards take 5, select card rank, right? Hand, select hand rank, needs to be an array, and we'll put a weight in there. Okay, good. So we got that. And then I'm going to use our utility class to help out again to keep this implementation small, but you could use it, you could implement it in the straight handmaker class. I'm going to do it outside because I'm going to use this same functionality when I do this straight flush handmaker class. So let's do it that way. I could say list of string. We'll call it straights, because imagine you could have more than one. Imagine all 7 cards were in ascending or descending order by 1, but you can only take 5 of them. So basically I'll get this collection and I'll take the best one of them. And imagine if we had utility, had a method which we'll make called get straights. Given an array of cards, it will return you this list of straights, and then you can process them as you need. And so I could say if straights dot count is greater than 0, that means we have at least 1. If straights count is greater than 0, we have to say hand win type equals, they call it straight. You can see below in the tests, we'd have hand dot card ranks equals straights dot first, right? Remember the enumerable method first just takes the first one in the collection, and get straights will make return it such that the best one occurs first in the list. That's how we'll make that jive. And then hand weight equals, just like we've been doing with the other ones, right? You can just use the weight field that was set at construction time. And finally return hand. If there were no straights, it just gives you that bum nothing hand. So that's all you have to do, but let's make sure we make this get straights method so this is legitimate. Go back into the utility. Where does my switch rank? Okay, rank weight. We're gonna make a new one. Call it public. Did I make this one? I hope I made this static. Good. Public. These all have to be static because they're in a static class. That wouldn't make sense otherwise. So we want to do this get straights. Let's implement that, and it's going to return a list of string, right? Public static list of string, we said. We'll call it, I think I copied that, good, get straights. and I'm sorry, this shouldn't be a string, it should be a string array. That's how we make the hands. They're an array of strings that contain the ranks. And then we passed in a card array of cards. Good. So for this, let's first set up our return type. List of string straights equals new list of string. We'll initialize that so we can use it. And then, so for the straights, right, we don't care about any duplicated cards. We don't care about pairs. So let's kind of filter that out first. Let's say var distinct equals cards select. And we can say card, we're going to convert the cards into a collection of their string ranks, right? It's the format we want. Enumerable has this distinct property. This will get rid of any duplicate ranks because we don't care. And then I'll say, I'll put this on a new line, order by descending rank utility rank weight rank, right? Okay, so these are giving me my cards, no duplicate ranks in descending order, so the biggest is at the front. And so let's see if we even need to process straights. Imagine we had everything paired up or tripped up, and we didn't even have enough cards to make a straight. There's no point in even processing, right? We better have at least 5 distinct cards if we want to even consider looking to make a straight. So if distinct count is greater than or equal to 5, that's the only condition where we need to even look. Otherwise, we can just get out of here. If distinct.count, otherwise, of course, we will return straights. And straights will get populated in here as necessary. So let's go over the distinct collection and try to make some straights. So I will say for int I equals 0, and I'll say I is less than or equal to distinct. If you don't like how I'm saying distinct count multiple times, you could sort of cache that. You can just make a local variable with that count value in there so you don't have to keep accessing it. What I'm going to do though is say distinct count -5, because I'm going to examine these in 5 card chunks at a time. That's why I'm saying -5. Once I don't want to overrun the bounds of the array because I'm going to look 5 cards ahead. So that's why this works. And then I can say ++I. Okay, so let's sort of take these chunks of 5 at a time and do something with them. String ranks. Think of it like we're making a little mini hand here, right? Distinct, and we're going to skip I, right? So to start I0, and we're not skipping anything, but as we go through each iteration, we want to jump ahead because we already processed the first card. Then we want to take, instead of cards 1 through 5, then we want to take 2 through 6 and then 3 through 7, right? That's why I'm doing this skip here. Skip I, we're always taking 5 because we're making 5 card hands, and then we're working with string arrays for these card ranks. So I've got a hand here, right? And I'm going to set up this little flag, bool makes straight, and to start, let's just assume it does, and we'll invalidate it whenever we find that it doesn't hold. So I'll say for, and you know what, I'm going to have, with this nested for loop, let's call it, just to be clear, hand index. So I'm going to use a card index in here. I don't want to confuse you with too many just weird letters bouncing around there. Skip hand index. I think I replaced all the I's. So here let's call it int card index equals 0. We'll say card index less than ranks.count. And then same usual thing, bump the card index. Define our scope for looking at each card. And then we could say, we basically want to make sure that these things are one apart, right? If there's a gap of more than one between any successive cards, then that's not a straight, right? Because these are ordered by descending. So we could do something like, if card index is less than ranks dot length minus 1, it's not the last one, and then we'll say and utility, we need the weight, rank weight of ranks card index. If that rank is not equal to the next card plus 1, then we have a problem, right? Or I should say we don't have a straight. Utility rank weight ranks card index plus 1. That's the next card. The hand should step down. So the previous card should be equal to this value plus 1. And that's why I have this card index is less than ranks length minus 1, because if we were on the last card and I tried to look ahead 1, we would overrun the bounds of the array. So it's not necessary to look past that. So in that condition, we know that makes straight would be false if that condition doesn't hold. And you can just stop looking at this hand. We know this hand is drawing dead in terms of finding a straight, so there's no need to continue processing it. Just break out and look for the next 5-card hand there. And then after your for loop, if you survive that, we'd say if makes straight, clearly you should take your straights and add that hand to it, ranks. Maybe you could call it hand if you want to call it hand. And so each time we'll get the straights in there. They were in descending order, so the biggest one will be the first in the array. And I think we already did the return straights, so good. This should hold. You can see it steps through each card and ensures that condition is true. So I think that completed straight hand maker by solving this problem. So we can go on to another hand maker class. After straight, we can do the flush. Let's take care of flush. That's a little bit different too. Public class flush hand maker inherits from hand maker. Copy the name, save a little typing. Public flush hand maker, just like we've been doing before, right? When types flush, I think it was called. Don't have anything to do in the body. We've got to override that abstract method, give it an actual purpose, actual work to do. Public override hand get hand, and it takes an array of cards. Needs cards to work with, right? Card array cards. Okay. And so I'll do my usual. I'll set up that hand results. This new hand, nothing. We could say cards take 5, and we'll select the ranks because the answer doesn't deal with cards, it deals with string ranks. Card rank, and we got to make it into an array. To array, and it needed a weight. I think I got that right. Okay, so that's sort of our default if nothing hits. And then again, I'm going to use the utility class to put the get flush cards in there that I can reuse with my straight flush hand maker class. So I'll say we can say string array flush, just imagine we have something just like we did with straights. Utility get flush cards given an array of cards. Just imagine we have something nice that will do that, give us all the flush cards. Then we could say if flush length is greater than or equal to 5, right? That's enough to make a full hand, full poker hand. Then we sort of set up that win type that we've been doing. Win type equals, we see they call it flush below. I can say hand card ranks should be equal to flush order by descending. Descending ranks we want. Order by descending. We want to take the best 5, the highest 5, right? That's your best flush. It happens with the highest cards. And then as usual, it's a string array. And then hand weight, the usual, just take the weight that was assigned at construction time. It was a flush weight. Easy peasy, right? And then you do the same thing, return hand. Looks just like what we've been doing, right? Pretty similar there. But of course the key, we gotta make sure we implement this. Just like with the straights, I'll go ahead and make this method too. So we can say public static, and we want to have something that will give us the flush cards. So I'll say public static string array get flush cards given an array of cards. And one way we could do this, let's go imagine we had an integer array of suit counts. It would tell us the count of each suit. And I could say, we'll just make a method that can handle doing that. Get suit counts, given some cards. And then we could say char suit equals get flush suit given some suit counts. It would go through and find the one that had 5. That's its job, right? And then once you know that, I could say if suit is not equal to, let's make a, we'll make a little constant to sort of handle this. We'll say, let me put it down here, private static read only char, I'll call it no flush equals, I'll just use 0 as a symbol for that, something that isn't needed. And then I can say if suit is not equal to no flush, then return cards where card, and a card has a suit, right? So we could say card.suit, that was one of the properties, equals the flush suit. Maybe you could name that flush suit if you like that better. And then we could say, of course, we got to convert it to ranks. That's what they like. Card.rank to array. And then otherwise, if there is no flush, I'll just return some bogus empty string array like this. Okay, but I kind of offset some of the work here, which, you know, is a good strategy in my opinion. So we should implement those. I'll say private static int get suit counts, get suit counts given an array of cards. And so we'll say int array suit counts equals new int 4. There's 4 suits, so if you want to set up a constant for the number of suits, you could do that. And then we could say suit counts. And what I'm going to do is I'm going to set up another enum for the suits because I find that helpful too. So let's include that with our other data at the top. We had some enums up here. Where were they? In types. Let's make another one. Public enum suits. And so for suits, we got to make sure they're the values between 0 and 4, right? So I can say hearts equals 0. I could say, what do we have? Clubs, diamonds, spades. That'll do it. I called that suit, so I'll go back to where I was. And then with that enum, I can sort of use those to access my array. I can say suits hearts, and arrays use integer values, so I'll just cast that enum to an integer, and then I'll sort of offset, I'll defer doing the actual work to another private method. I'll say get suit count, and now I need to give it a char to look for and cards to look through. So also remember we found out these numbers over here, 98. I'm going to make some constant to cover those too, because those are ugly. So I'll say, let's do this. We can say public static read only char. I'll say hearts. We'll do this for each one of them. Hearts was 9829. I'm going to cast it to a char because that's our type. And I'll make 4 more of these for the other suits. That's a little bit nicer to look at. So we're going to have clubs, diamonds, spades, and oops. Clubs was 9827, diamonds was 9830, and spades was an oddball that was 9824. So good, those will be helpful too. I don't have to refer to those ugly numbers, because those definitely, if I saw those, I wouldn't know what the heck that was supposed to represent if I just saw that number floating around. So for this get suit count, we can use those handy names. So I'll say utility hearts, and we've got to pass in the cards to use. I can repeat this for the other 4 suits. Whoa, I didn't mean to run. I think I fat fingered there. So we'll say clubs, diamonds, spades, and of course we got to make these match too. Clubs, diamonds. Hopefully you agree these read better than just using weird numbers in the place. So get suit counts. Get suit counts should actually return an integer array, not an int. Sorry about that. Then finally I can return my suit counts. But let's make sure we make good on the work that I deferred. I should say private static int get suit count, and that's going to take, for get suit count, it should take a suit and some cards. Char suit, card array, cards, and this will be short and sweet, so I'll just define it sort of in place. I can say cards, have this count method, right? Sometimes if you don't pass any parameters with count, it just counts every element, but what's nice about it is you can give it a condition. I could say where card suit equals suit, right? Okay, I took care of that. Was there another method that I didn't take care of? We had get suit counts, get flush suit was the other one. So I'll say, yeah, I don't think, did I make that? Get flush cards. Get flush suit. Yeah, I gotta make get flush suit. Okay, so get flush suit, private, static, char, get flush suit if there is one, and it's going to take integer array of suit counts, and then basically we're going to check if there's 5 of any suit. So we can say if suit counts int suits hearts is greater than or equal to 5, we want to return hearts, and say, and so on for the other suits, right? And then finally, if nothing happened, return, we called it no flush. So let's do clubs, spades, something like this should do it. Okay, so I think our implementation's complete, which if it is, that would finish off our flush hand maker, I believe. Let's get back there. Yeah, because we just had to get flush cards. And we kind of deferred all that other work outside the class. We'll reuse it with straight flush hand maker. So good. I'll move on from flush. Okay. So what else do we have to worry about? We have a full house. So that's kind of like with pairs. A full house is 3 of a kind and a pair. Public, whoa, not trying to yell at you there. Public class full house hand maker inherits from hand maker. We've got a constructor as usual. Base, we'll give it a weight of full house. Public override hand, get hand, given an array of cards. Okay, so how do we make a full house? We're gonna want, we need a 3 of a kind, right? And we need the best one because there could be more than one. Technically, there could be 2. So I'll say var best trips, short for 3 of a kind, trips. And I'll say cards group by, we want to group by the rank, right? That's what we've been doing. That's what determines matches. And I'll say where the match count is equal to 3. And then we're going to convert this collection to an array, or I should say a collection of strings. So we'll say key. Key happens to be the rank because that's what we grouped by. And then I'll say order by descending. We should be able to use the rank now because we've converted back. So I'll say rank utility rank weight. Give me that integral value for that. And then since I want the best one, I'm going to use this first or default. If you just use first and there isn't a first, I think you get an exception if I remember that right. So this will just give me some default of the type if it isn't found. I'll set up my bogus hand to return if nothing is there. So nothing. We could have cards take 5, select the by rank. They only care about the ranks. We make it to an array. We give it a weight. That completes our hand constructor. Okay. And so if there are no trips found, we're done, right? You can't make a full house if you don't have 3 of a kind. So we can say if string is null or empty, best trips, then we're done. Return hand. Remember, don't go looking for things if you can't find them, right? It's just wasted processing. And then I'm going to sort of set up the non-matched and pairs things again to see how we can combine them. So I'll say var non-matched, and that will be cards where it's not contained in the best trips. That's the one we're using for the 3 of a kind. We don't want to reuse it for the pair, right? It'll hit as a pair because there's more than 2 of them. Unless you look for exactly 2. So I'll say card where best trips does not contain the card rank. Okay. And then we'll order those by their rank. Order. Here, I'll put down a new line. Keep this readable. Order by descending. And we can say, take that card and say utility rank weight card dot rank, and make it into an array. Okay, that was non-matched, meaning it didn't match for our trips. And then I can say we want to take pairs out of that. We don't want to take pairs out of our best trips. Of our pairs, but if it was a lower 3 of a kind, maybe that would be eligible for a pair. So I can say var pairs equals non-matched group by, and we'll do it by the card rank. And then we want to see where match.count is greater than or equal to 2, because you could have that oddball case where you had another 3 of a kind that you could use for the pair. That's why I'm doing it like this. And then I could say select match.key, which is the rank. And then we want to order those by descending rank as well. Order by descending. We have the rank. We could say utility rank weight for this rank. So now we have a collection of rank pairs. Good. And so if we're still at this point, obviously we do have trips present. So we'll additionally check that we have a pair, because if you have only the trips and not a pair, then you still don't have a full house. You have a 3 of a kind. So we'll say if that equals 0, return hand. You don't have a full house, return hand. Otherwise, we'll set up the win and win type equals, they call it full space house, hand card ranks equals new string, and we'll say best trips and pairs dot first. Note there are pairs present. If we survived here, if there were no pairs, we would have been gone already. So I can get away with that. And then hand weight should just be the weight that we set up in the constructor. And weight. And then finally just return your hand, your winning hand. You hit the full house at this point. And so yeah, that's a full house. We're getting pretty close. We just have to do the 4 of a kind and a straight flush, and we're looking pretty good. So we'll say public class, to shorten this, I'm going to call it a quads hand maker. By quads, I just mean 4 of a kind. Hand maker. Define the scope of my class. Make my constructor. Whoa. Sorry about that, jumped tabs there. Quads hand maker, there's my constructor. Must have fat fingered a hotkey there. Quads hand maker, so nothing there. We're going to invoke the base constructor with a win type of 4 of a kind, I think we called it. Nothing to do in the body. Public, override that abstract method, which returns a hand. It was called getHand, given an array of cards. All right, so how do we do this for quads? I hope you're pausing these and you could try them out. They're pretty similar to what I've been doing so far, so feel free to do that. For our quads, we're looking for 4 of a kind. So we'll say cards group by card rank. And hopefully you're getting lots of practice with chaining these methods and LINQ methods. It's probably good. Where the match.count equals 4, right? Because we're looking for 4 of a kind. We'll say select. We're going to convert this back to those ranks, the string ranks, match.key, and we'll order by descending rank. Order by descending, and we have a rank, utility, rank weight, rank. Okay, so we have possibly 4 of a kind there, but possibly not. We'll set up our dummy hand equals new hand with nothing, cards, just take 5, select card rank, to array, give it nothing weight. Okay, so now you can imagine if quads.count is equal to 1, you have a winner. And you'll modify that hand object. Otherwise, or in either case, I should say, you'll return hand. Hand win type equals, they call it, it's kind of cut off on my screen, but it says for of a kind, hyphenated, hand card ranks is going to be a new string array of quads dot first, which definitely exists, and I guess we want the best card here. I'll make this in a separate variable so you can see it. Var best non-match would be cards where its rank is not equal to quads dot first, right? We don't want to use one of the quad cards. It's got to be something not part of the four of a kind. And then I can say order by descending card utility rank weight card.rank. We got to convert this back to a string, select card card.rank, and then we're going to take the first, because we only want one of them, right? We have four of a kind at this point. We only need one card. And then I can say best non-match for this. And then we return the hand. I think that covers us for four of a kind. So then we got the straight flush hand maker, and then we got all of our hand makers. Public class straight flush hand maker inherits from hand maker. It is one of those. Public for our constructor, which takes 0 arguments, calls base with when types straight flush, I believe. Nothing to do in the body. Public override hand, get hand given an array of cards. Okay, so let's do this to make a straight flush. Since we have those utility methods broken out, I get to reuse them here. That was sort of my motivation there. Keep this thing relatively easy. So I can say, basically, we'll check for straights, we'll check for flushes, and then we'll see if they coincide, if they exist with the same cards, and then we'll know we have a straight flush. So I could say list of string array. I think that's what we called our straights. I could say straights equals utility gets straights, given some cards, right? Got to give it something to work with. Then we could say our flush cards would be, let's call it flush ranks. You can call it flush cards if you want. We made another method called get flush cards, given some cards, if they exist. And so as usual, I'll kind of set up this loser hand to return if nothing is there. New hand, nothing. We'll just take 5 cards, take 5, select card rank, make an array out of it, and I'll give it a nothing weight. Okay, so we possibly have straights, we possibly have flushes, we might have nothing. If we don't have either, we're sort of done, right? So I'll say for each var straight and straight. Let's look at all the straights, if there are any. This will all get skipped over if there aren't any. So what I can do is find out where these two collections meet. So I could have had multiple straights. I'm going to examine each one and compare it to the flush ranks and see if they have anything in common. So I could say var common could be straight intersect, right? This is an enumerable method you can look up, and flush ranks. I want to see if these two sets coincide. If they do, I have a straight and a flush. And I could say if common count is greater than or equal to 5, that means, okay, we matched at least 5 cards, enough to make a hand. We can say hand win type equals, they call it straight flush hyphenated. Straight flush, we'll say hand card ranks will be the straight itself, which was ordered the way we wanted, with the best ones occurring first. We'll say hand weight, the usual thing, give it the weight that was set up at the time we constructed this. And then finally we want to break out. We can stop here. We don't need to check lesser straights, right, if we hit a better straight with a flush. So I'll say break to break out of this for each loop. And then finally, once you've done that, you can return your hand. If the straight flush occurred, this hand would have been updated to have winning information in it. So that takes care of that. Good. Now I want to get on to, if you remember my document, we're at this point. This was the abstract class. We have all of our makers. Now I want to look at this win analyzer thing. And this is going to be really easy to do now that we have all these hand makers. We're just going to make a collection of them and then call make hand, which all it has to do is call get hand on each one of these, and then put them all, the results, all the 5 card hand results in a collection, sort them by their weight, and if you have a win, take the first one, the biggest one, the most weighted one. So let's go back and make this win analyzer. How should I do this? I'll do this up top. Maker card hand. Okay, there's our top. Should we do it? Let's put it. Put it right here, right before hand maker. Okay, so let's do the win analyzer. Feel free to modify the names of these as you like. I'm going to make mine a static class, but I suppose you could make it non-static if you had different kinds of poker games you were playing. Maybe you had one win analyzer that worked with games that had multiple decks where 5 of a kinds were possible, or you know, you wanted to deal with wild cards, or I don't know, some other variation. But our work here is just focused on the one thing, so we're not going to go crazy making a bunch of extra features. So win analyzer, I said it's going to have a method called make hand. That's the main thing that's called. So it's going to be public static. It's going to return a hand. I called it make hand, I think, in the document. And like everything else, it worked on an array of cards. You passed in the cards, it'll give you the best poker hand for it. So let's set up our collection of hand makers now that that's all ready. Be private here. It's going to be static. The class is static, so everything's static. There are no instances of win analyzer. I'll have a list of hand makers, and I'll call that, we'll just call it makers for short, whatever you want to call it, it's fine. New list of hand maker. I'll just initialize it right here so it's ready for use. And then I'm going to do this private static void load hand makers method. That's going to get everything ready for us at the start. And so it's just going to basically fill up this collection with the makers we want. And the way I can get this thing to be invoked is, you may not have known this, but with a static class, you can actually make a static constructor, which sounds kind of weird. But before anything is used in the class, you're sort of guaranteed that this will fire. And so I'm going to call this load hand makers here, just so everything's ready. And then in here, as you can imagine, it's just a matter of saying makers add, and then we want a new pair hand maker. And because pair hand maker is a hand maker, that's fine. It can be assigned here. That's the power of polymorphism. So remember that pair maker didn't need any parameters. So I think we can just copy this for all the classes. And what do we have? We had pair handled one pair and two pairs, so we had trips. What else did we have? We had straight, we had flush, we had full house. I think we had quads for 4 of a kind, and we had straight flush. Does that look like all of them? Pair trips, straight handmaker, flush handmaker, full house, quads, and straight flush. I think that's right. I think that's all of them. Just make sure you have all of them. And so remember, before make hand is called, then this load hand makers will be run and all these things will be populated. So that's good. Now make hand is pretty easy, right? Because we did all that upfront work. So we can say list of hand. We're going to get a bunch of hands from our makers. We can say hands equals new list of hand. And then what you can do with your makers, you can say for each var hand maker in makers. You can say hands add, and then you want to say hand maker get hand for the given cards, right? And this will go through all of your hand maker types and get those, try to make hands for each of them. Okay, so then you have the possibility that there are no wins, right? You may not get a win from all your different types. So to handle that, you can say if hands all hand, remember we had a win type equals nothing, right? Remember that? So this is saying, you know, it checks through all of the hands, and it came back, there's no wins found. We can return a junk hand, but that we wanted it ordered by descending. So I guess if I should have made the losing hands. I can't remember if I made all of them do this or not. Just to be safe, I'll just say return new hand. I'll make one here. But if we made them all do the cards in descending order, then I could just take hands dot first, since it would all be nothing, right? Actually, I'm kind of tempted to do that instead of doing this. What if we, here, I'm going to try it this way first. See if we can make this work. Return hands dot first. So ideally, even if there is a win will be sorted first. So let's make sure we get our sorting behavior in there too. So what we want to do is say hands where hand win type. Actually, I don't care about the win type. I should be able to generalize this. So let's do the hands order by descending. Hands order by descending. Hand has a weight to it, and then first. How about that? Something like this. Then if they're all losers, the first one should have all the sorted cards. If we get errors, then I probably, in one of my handmaker class, didn't sort the cards in descending order. For some reason, I have it in my mind that I had a couple where I just took 5 cards randomly, but we'll see. So something like this. Hands ordered by descending. Okay. Let's try that. I'm obviously, with all this typing, it's almost guaranteed I made some errors, so let's see. The typer namespace list, yep, we didn't bring that in. And we know system collections generic for list, and we know using system LINQ, because we use the heck out of LINQ. So I'm gonna bring those two in for sure. Hand does not contain the definition for card ranks. Let me see what I called it in the hand class. So I just called it cards. What if I change it? Card ranks. Let's see if this makes it jive. Name cards does not exist in the current context. Yep. So we called it card ranks. I'm just sort of peeling these errors off the top. Cannot type list of string array to a list of string. I think I remember that on line 152. We had, yeah, this should be a list of string array, not list of string. When type does not exist in the current context. It probably should be when types. Name rank does not exist in the current context on 105. Where's 105? Yep, I used rank, but the variable, the lambda variable was card, right? So I should say card.rank. The name card does not exist in the current context. On 107, that's, oh, that's weird. I didn't even put the card. So still cards. Yeah, so sheesh, what kind of, that wasn't even a lambda. I'm not sure what I was thinking there. Sorry about that. Okay, so we got some results. Test failed. Let's see what we did. Whole cards. This could be the thing with nothings. Yeah. Test failed whole cards. Expected nothing. We returned nothing. But the ranks, look at what we did. Ace, queen, 9, 6, 3. And obviously there's a king in here. You can see from our whole cards. So yeah, this is a case of one of my hand makers. Let me make sure I'm making them all return losing hands with the biggest cards. So I'm going to go to my hand makers. Let's see pairs. What does it do when it loses? Yeah, this isn't going to cut it. Non-matched. So actually, I don't even think I need to use non-matched. We could probably just say cards order by descending. Utility, rank, weight, card.rank, take 5. We want to convert it into a string, into strings, not cards, right? So I'll say card to card rank to array, something like this. And I wonder if I just copy these, I could probably repeat this for my other losers. And straight hand maker. flush hand maker, full house hand maker, quads hand maker, take 5, and straight flush hand maker. Maybe this is the problem. With the losers, we need the biggest possible hand even for the losers. So that's all the hand maker types. Let's see if this got us anything. Expected on 108. Oh, I copied something with parenthesis problems. 108. What did I do here? To array. Yeah, I gotta close the. Here. That's why I write these on new lines here. This window's just so small. Cards ordered by descending. Take 5. Should be a little easier to read. By descending. Yeah, that should have had another parenthesis. Then take 5. Then select card. Let's try that. I was on 105, I believe. Suppose that's a little excessive. That was pair hand maker. I'll just update these. Straight hand maker. Flush hand maker. Full house hand maker. Quads hand maker. Straight flush hand maker should be all of them. Let's see if I got that right. Okay, so what's our next error? Test failed, expected nothing, ranks ace, king, queen, jack 9, type nothing. Cards. What did I do? Oh, you know, we didn't even get this thing set up. I did so much coding. I skipped over that. So here, let's get back to our, wow. Yeah, so I forgot the main method of the challenge that they stubbed out for us. It's just returning this garbage right now. So we didn't even use our win analyzer. Yeah, might want to include that. So let's add that in. We will then say we've got to sort of make one big collection of cards. So I'll say card array cards is new card 7. Because for my purposes, I don't care about the distinction between whole and community cards. But in reality, when you're comparing hands against other players, then the whole cards matter very much, you know, about who wins or if there's a tie. So. But we're not worried about that here. So I can say, actually, I wonder if I should just make cards. Let's do it like string array all cards equals whole cards concat like we used before with the community cards to array. Okay, and then we can say for, we'll iterate over all the cards into I equals 0. I is less than all cards dot length plus plus I. And then we will construct, we'll sort of convert this input into the card form that I used for this challenge. So I could say char suit character equal to all cards, because I need a suit and a rank to make a card object, right? So I'll take all cards I, and then we want the last character of it. So all cards I dot length -1, right? Remember that these can be either 2 or 3 characters long. So but in the case of the suit, it's always the last character. That's why I did it like this. So yeah, get the current card and then index the character, which is its length -1, to get the suit character. And then we have int, we'll consider the case. We've got 2 cases. Remember that weird thing I mentioned at the beginning where your rank could be 10, in which case it has 2 characters in it. So I can say all cards I dot length equals 3. If it does equal 3, then the rank size is 2, otherwise the rank size is 1. This covers that case where you have a 10. And then I can finally say cards I, and we can make a new card equals new card, and we needed a suit and a rank. So it should be suit char, and then our rank would be determined as all cards I substring starting at 0 and grabbing the rank size, which will be either 2 or 1. And at that point you have all the cards. This cards array is loaded up. So then finally we can leverage all the work we did. We could say hand best would be equal to win analyzer. I think it was called make hand, given the cards. And then we set up our hand to accommodate this anonymous type they wanted. Remember at the top here they had string type and ranks. That's why I set up hand that way. So I can say return, I'll give them this, that's the win text, and they want the ranks, best card rank, something like this. All right, let's see if we get some more realistic results now. Okay, we hit an error. So we definitely passed some. Expected 4 of a kind, but we returned that it was a full house, ranks 3 and 2. Okay, so they had a 4 and a 3. Yeah, that probably was some subtle thing there. Let's check the 4 of a kind and the full house. Well, it should be the 4 of a kind logic that we should check, because it should trump if it works right. So let me see what I did with 4 of a kind. 4 of a kind. Let's check for some bugs in the quads hand maker. So we had quads grouped by where the match count equals 4. Okay. What else do we have? Select by key, order by descending, rank seems okay. By descending. Hand. We got our nothing hand if quads count equals 1. So we should have hit quads, right? Let me see that hand that they gave us a 2 3 2 2 3 3 2. So yeah, there are definitely 4 2s there. By Okay. Quads. Look at what I do. So, I mean, pretty straightforward. Quads that first. Let me add a print line here. Console right line. Quads dot first. Something like this. Let's see what we get. Sequence contains no elements. First or default. Okay, let's see if we get back there. Quad, so it recognized that 2 was the 4 of a kind. That's good. The count should have been greater than 1. It made quads first. That's non-match. Natural type full house. Did I not set my weight? Oh, goodness. Sure enough, look at that. I think as I wrote an extra line in here, I was used to writing 3 things. How about this? If the win isn't weighted, the full house is gonna trump it, right? We gotta set the weight correctly. Let's try that. Bingo. Dang, that was... Ugh, sorry about that. Annoying. I'll get rid of this print statement. Hopefully you are using print statements as needed. We passed all the tests. I'm going to expand this quick. I'm going to get rid of this print statements here. I'll just dress this up a little bit. So yeah, we made collection of cards. We didn't care about whole or community. Just we're working with all 7, trying to make the best 5-card hand. We converted from the input format, which was kind of crude, into this cards data structure that I liked. And then, man, this sure was easy to do after we made the hand makers, right? You just say, hey, give me the best hand that you find, and then I'll give you this anonymous type you want with a string representing what kind of win it was, and then I'll give you the cards associated with that win. We made some pretty simple enumerations that made the code a little more readable, I think. We had some simple data structures here, card in hand. I almost led you astray here on Win Analyzer, but it was really simpler than that. We can do this. All the losing hands just took the biggest ranked cards, so it can really boil down to be this simple. That is really nice and simple, isn't it, to look at? And then note, yeah, if you wanted to add more features, you could have different kinds of hand makers, like I said, for 5 of a kind, or I don't know, different kinds of hands that can come up with wilds or whatnot. We had the abstract hand maker class. That looks good. Really simple, right? You got this concept of giving me a 5-card hand based on some examination type. We weight them accordingly with different weights. We didn't even bother. It was so simple, we didn't need anything even in the constructor. We could just kind of weight them within the class, the subclasses themselves. And then pretty common things, just grouping things by their rank in the case of matches, returning winning hands when they were to be found. This all looks good. The straights thing, flush thing, didn't like the utility. That's the way I set it up here quickly, to reuse that logic with the straight, the flush, and the straight flush. But beware of utility classes. They tend to be dumping grounds. Don't recommend them in the future. They kind of give me a code smell, like a design is incomplete. So if you want to criticize me on that, that's fair. Full house, yep. Quads, that'll work. Straight flush then was pretty easy because of that other legwork we did. And then finally, yeah, we had this concept of ranking things, giving them weights that helped with sorting. Get straights, pretty straightforward. Give us the best straights. Flush. I sure liked these a lot better than working with weird numbers. And I think that's about it. I think I'm going to submit mine like this. If you made it this far in the video, you are awesome. You are really dedicated and love all things programming, and I would bet that you have a bright future. I really appreciate the views. I tried to get through this as quick as I can without glazing over things too much, but you know where to find me if you have those questions. Actually, you know what? I shouldn't even claim victory yet. Let's hit the attempt. Okay, that works for me. But yeah, you don't want to get overly confident. So I was happy with this. I'll go ahead and fire mine off. You do the same, get your kata points, and this might be one, these higher Caillou challenges are ones to really look through other people's solutions, and because they're going to vary a lot, right? There's a lot of opportunity to do cool tricks and design practices and design patterns. So maybe worth your time scrolling through a bunch of these. I'll do that on my time. You don't have to watch me reading through other people's solutions. Other than that, yeah, I'll see you in another challenge. Thanks again.